In the physical world, people are familiar with how cloth and paper react to their actions. These flexible materials follow understandable rules of physics, allowing people to use the material to view information in a variety of meaningful ways. Building on the familiarity with cloth and other similar materials, we have implemented a virtual, physically simulated cloth on the Smart Table. People can interact with this virtual cloth through objects and through directly touching the cloth in order to explore the information. We introduced rigid, virtual artifacts that serve as lenses when they are placed under the cloth, allowing details that were previously difficult to see or understand to be made meaningful. A person can place an object in the environment by selecting an object from the side menu. Using a simple touch and drag gesture, the object can be moved around the scene. Multiple objects can be added and then moved simultaneously. The height of the object, which corresponds to the magnification that it gives, is controlled by the pinch gesture. The maximum height is limited to prevent penetration of the cloth. A three-finger gesture is used to control the width and the length of the objects. Once the objects have been placed to create an initial scene, the cloth can be dropped onto the objects by pressing the cloth case. This causes the cloth to come out of the case and fall into the objects. We can then apply our 1, 2, and 3-finger alterations to the objects underneath the cloth by touching the objects as before. When objects are touched, the cloth automatically turns slightly transparent and raises above the object. When released, the cloth once again turns opaque and falls upon the objects. By moving objects, we can change the magnified area within the cloth data. Changing the width and the length of the objects allow the magnified area to be changed in shape. Using pinch to change object height allows the magnification level implemented by the object to be changed as well. By touching the cloth rather than the objects underneath, the cloth can be dragged about to change surface tensions and to straighten wrinkles. We can provide similar detail and context functionality to several existing lenses. We demonstrate this using spherical as well as square-shaped objects, which illustrate different magnification drop-offs. Our system also allows new types of interaction with this information, such as the creation of bridges between lenses, and the ability to stretch out areas of interest while allowing less important areas to become wrinkled. This system demonstrates the power of visualizing 2D information on 3D virtual cloth. By leveraging people's understanding of how physical cloth reacts in the real world, our system can provide the flexibility necessary to support creative manipulations of information with multiple fingers, multiple hands, with multiple people, all at the same time.